Good morning, friends. In Wave Optics of today's, we discuss the number of MCQ asked in All India PMT and also the Neet exam and also in question. Today we are going to discuss about what are the numerical or the MCQ type question asked in Neet exam. So first question asked in 2014, if the focal length of the objective lens is increased, then magnifying power of, that means we have to discuss about what is the magnification of telescope and microscope. Yes, the focal length of objective lens is increased, right? What's happened? If the focal length of the objective is increased in case of a microscope and in case of telescope, about the magnification. So options are given. Microscope, that means the magnifying power of microscope will increase, but that of telescope decrease. Second option, magnifying power of microscope and telescope both will increase. Third option, magnifying power of microscope and telescope both decreases. And last option is that magnifying power of microscope will decrease, but that of telescope is decreased. So how we judge about the correct answer? For that purpose, we have to know about the equation of magnifying power of microscope and telescope. Therefore, magnifying power of microscope is equal to LD upon FO plus FO plus F. D is the diameter of objective, L is the tube length, that means the distance between the eyepiece and objective, FO is the focal length of objective, and FE is the focal length of eyes. Here the focal length of the objective FO increases. Therefore, from this equation we can say that magnifying power of microscope will be decreased. And for a telescope, magnifying power of telescope is FO upon LD. So from this equation we can say that as the FO increases, magnifying power of telescope increases, while for the microscope decreases. Therefore, D option is right. Magnifying power of microscope will decrease, while of telescope increases. Therefore, our D option is right. So this type of the question can be, we require the knowledge of the magnifying power of microscope and telescope. From this equation we give the answer of this question. Now next is 2015, that is asked in Neet exam. For a parallel beam of a monochromatic light of wavelength lambda, the diffraction is produced by a single slit of width A. That means the width of a slit is given A, is of the order of wavelength of the light. If distance between, if D is the distance of the screen from the slit, capital D is the distance, the width of the central maxima will be. For that purpose, first we find out the width of a central maxima on a screen, that is the distance between, that is the central maxima. Width of a central maxima is the distance between first minima. This distance. That gives the width of a central maxima. Therefore, we can write width of a central maxima is equal to distance between 2 minima. Distance between two minima. Right? Therefore, condition for first minima. Now, condition for first minima. Condition for first minima is equal to d sin theta is equal to n lambda. Here n is equal to 1, d is equal to n. Therefore, sin theta is equal to lambda upon a. Sin theta is equal to lambda upon a. Therefore, linear width is equal to d into 2 theta. Sin theta, theta is very small, so therefore we can consider the theta is equal to lambda upon a. Therefore, 2 lambda d upon a. That is our answer, 2 lambda d upon a. Again, now we require the width of the central maxima. Width of a central maxima is the distance between first two minima, either side of the minima, for either side of maxima. The distance of the central maxima is equal to distance between minima. Now, condition for first minima, d sin theta is equal to n lambda. Here we substitute n is equal to 1 due to first minima, and d is equal to a. That is the distance between the two slits already given. There is a. Therefore, sin theta is equal to lambda a is equal to theta. Therefore, linear width is equal to capital D into 2 theta. That means the distance of the screen from the slit into 2 angular width. Therefore, 2 as it is. Now, D capital D and theta is equal to lambda upon a. Therefore, 2 lambda capital D upon a. After that, next is asked in 2015. In a double slit experiment, the two slits are 1 millimeter apart. That means the distance between the two slits is given. And the screen is placed 1 meter distance. Capital D is given. A monochromatic light of wavelength 500 nanometer is also given. What will be the width of each slit for obtaining 10 maxima of double slit within the central maxima of the single slit pattern? Therefore, in double slit experiment, the width of the 10th maxima in double slit, width of 10th maxima is d sin theta is equal to 10 lambda. Therefore, sin theta is equal to 10 lambda upon d. 10 lambda upon d. Clear? And in single slit, width of central maxima, width of central maxima is sin 2 theta is equal to 2 lambda upon d dash. 2 lambda upon d dash. Right? But sin theta is equal to this. Sin theta is equal to this. Therefore, 2 lambda therefore 10 lambda d is equal to 2 lambda upon d dash. Therefore, d dash is equal to d by 5. D is given 1 millimeter, so 1 upon 5, it means the 0.2 millimeter. Now listen here, what we obtain. In double slit experiment, here, in whatever the distance we obtain the 10 maxima, This in same way, the central maxima is obtained by using the single slit. Therefore, in double slit, the width of the 10 maxima is d sine theta is equal to 10 lambda. Therefore, sine theta is equal to 10 lambda by d. Okay. Now, in single slit, width of the central maxima is sine theta is equal to 2 lambda upon d dash. Both we consider compare. There is the angular width, there is the width of the 10 maxima. Therefore, both widths are same. Therefore, 10 lambda upon d is equal to 2 lambda upon d dash. So here, pi, 10 lambda, 2 lambda cancel. Therefore, pi is remaining. Pi by d is equal to 1 upon d dash. Therefore, d dash is equal to d by pi. So it's equal to 1 by pi millimeter. That means the 0.2 millimeter is the width of a slit. So thus we obtain the width of a slit, each slit. Now next is asked in 2016, the intensity of the maxima in Young's double slit experiment is I0. The distance between the two slits is given pi lambda, where the lambda is the wavelength of light used. What is the intensity in third of one of the slits on the screen placed at distance capital D is equal to 10D? Yeah, there is the width of a slit is given. And on the screen, we obtain the maxima at x by 2 distance. That means this x distance is equal to d by 2. And this distance is capital D. Therefore, path difference is equal to xd upon d. So it's equal to x is equal to d by 2 upon d. Therefore, capital D is given the 10d. So 1 times dd cancel. Therefore, d by 20. And now, that is given path difference is equal to pi lambda upon 20. The value of the d is pi lambda upon 20. Therefore, lambda by 4. Therefore, sine theta is equal to lambda by 4. And lambda is given to 2 pi. Lambda is given 2 pi. Therefore, 2 pi by 4 is equal to pi by 2. Therefore, theta is equal to 90. Theta is equal to. Now we require the intensity. Now we require the intensity at that point. So from Malus loop, I is equal to I0 cos square theta. Right? Therefore, we can write the theta by 2. That means the 45. Therefore, I0 into 1 upon root 2 whole square. Therefore, I0 by 2 is the intensity at that point in the front of the even slit on the screen. Again, the intensity at the maximum in Young's double slit experiment is I0. Now, the distance between the two slits is in order of pi lambda, small d is, where the lambda is the wavelength of the light. Now, what will be the intensity in front of one of the slits on the screen placed at d is equal to 10d distance? For that purpose, the path difference is equal to xd upon capital D. Therefore, in sin theta, the sin theta is equal to d into d by 2 upon 10d. dd cancel. Therefore, d upon 20. But the d is given the pi lambda. Therefore, pi lambda by 20. Therefore, sin theta is equal to lambda by 4. But the lambda is equal to 2 pi. Therefore, pi by 4. Pi by 2. Therefore, theta is equal to 90 degrees. Now, after that, we are using the Malus loop. I is equal to I0 cos square theta by 2. theta is equal to 90 by 2, that means the cos 45. Cos 45, 1 upon root 2 and square, therefore 1 upon root 2 square. So I0 by 2 is our answer. Now comes the next numerical asked in 2015 in Neet exam. At the first minimum adjacent to the central maximum of a single slit diffraction pattern, the phase difference between the Huygens wavelength from the edge of the slit and the wavelength from the midpoint of the slit is. We have to find out what is the phase difference between the two waves. One is at the edge and second is at the center. Right? For that purpose, here we use the diagram for this purpose. So here the slit are S1 and S2. There is the S1, there is the S2. Okay. Now there is our screen. There is our screen. Here we consider the point P. So here there is the path difference, there is the end. Then this point is our S. This distance is, there is the slit and screen is capital D. Clear this? Oh. So here there is the right angle triangle. So there is the right angle. This angle is theta. This angle is theta. Therefore, for triangle S1 ASN, sin theta is equal to sin theta opposite to the adjacent. So Sn upon SS1, Sn upon SS1. So is equal to delta x1 upon a by 2. Because this distance between the two slits is it. So here the SS1 is the half distance, there is the a by 2. Clear? Therefore, delta x1 is equal to a by 2 sin theta. A by 2 sin theta. For first minimum, now path difference. For first minimum is a sin theta is equal to lambda. A sin theta is equal to lambda. Right? Therefore, sin theta is equal to lambda upon A. Therefore, delta x1 is equal to a by 2 into lambda upon A cancel lambda by 2. There is the path difference. Now, phase difference. Now, the phase difference is equal to K into path difference. K is equal to phase difference delta phi is equal to K 2 pi upon lambda into path difference is lambda by 2. Lambda by 2, lambda by 2 cancel. Therefore, pi radian is the phase difference. Is our answer. Again, here we consider the triangle S1 SN, right? Because here we have to find out the phase difference between the two wavelengths. Huygens wavelength, one is from the edge of the slit and second is from the center of the slit at point P. So first we have to find out the path difference Sn. Path difference delta x is equal to a by 2 sin theta is equal to path difference. Now for first minimum, condition is that a sin theta is equal to a lambda, therefore sin theta is equal to lambda upon a, we substitute in path difference, therefore lambda by 2. Now the phase difference is equal to wave vector into path difference. Wave vector is 2 pi upon lambda, path difference is lambda by 2. So lambda by 2 is cancelled out, therefore pi radian is the phase difference. Now next asked in 2015, if the two slits in Young's double slit experiment have the width ratio is 1 by 25. The width of slits are W1 and W2. That is given as I1 proportional to W1 and I2 proportional to W2. This ratio is given W1 upon W2 is equal to I1 upon I2 is equal to 1 by 25. Then the ratio of the intensity of the maxima and minima in the interference pattern will be. What is the ratio of intensity, maximum and minimum intensity? So here we obtain the ratio of the intensity I1 upon I2 is equal to omega 1, that means the width of a slit, omega 1 upon omega 2, right? Therefore we can take, so from this equation, omega 2 upon omega 1 is equal to I2 upon I1 is equal to 25 by 1. So we can add under root of I2 upon I1 is equal to 5 upon 1. But we know that I proportional to the S square. I proportional to the S square. Therefore, I2 upon I1 is equal to A2 upon A1 whole square. A2 upon A1 whole square. Right? So, therefore, A2 upon A1 is equal to root I1 upon root I2. Root I2 upon root I2. Therefore, the maximum of intensity I maximum is equal to A2 plus A1 whole square upon I minimum is equal to A2 minus A1 whole square. So as we substitute this value A2 and I1, A2 is equal to root 5. Right? So thus we obtain the ratio of 6 by 4 whole square, that means the 3 by 4 whole square. Three by 4, therefore 9 by 4 is our answer. Now listen here, we are going to use the equation of intensity. Intensity is directly proportional to the width of the slit, I proportional to the W. Here the ratio of the width of the slits are given 1 by 25. Therefore, omega 1 upon omega 2 is equal to I1 upon I2 is 1 by 25. After that, we also know that the intensity is directly proportional to the square of amplitude. So I proportional to the square. Therefore, this way we find out the A2 upon I1 upon I2 upon I1 is equal to A2 upon A1 whole square. Therefore, A2 upon A1 is equal to under root of I2 upon I1. Now, the I means maximum is the A1 plus A2 whole square and minimum is A2 minus A1 whole square. So, if we substitute the value we obtain, the ratio is 9 by 4. Now, after that, in a deflection pattern due to a single slit of width A, the first minimum is observed at an angle 30 degrees when the light of wavelength 5000 angstrom is incident on the slit. The first secondary maximum is observed at an angle of, at which angle we obtain the first minimum. First maximum, right? Okay. Now, for first minimum, condition for the first minimum, A sin theta is equal to lambda. Right? Sin theta is given, theta is equal to 30. So it's equal to A sin 30 is equal to lambda. Therefore, lambda is equal to a by 2. Therefore, a is equal to 2 lambda. A is equal to 2 lambda. Now, condition for first maxima. For first maxima. Condition is that a sin theta 1 is equal to 2n plus 1 lambda by 2. Therefore, 3 lambda by 2. Therefore, a sin theta 1 is equal to 3 lambda by 2. Now, already we obtained the value of lambda. Lambda is equal to a by 2. For the value of a, that is the 2 lambda. Sin theta 1 is equal to 3 lambda by 2. Lambda, lambda. Cancel. Sin theta 1 is equal to 3 by 4. 3 by 4. Therefore, angle at which the first maxima is obtained, theta 1 is equal to sin inverse 3 by 4. Now, in our reflection pattern, the first minima is obtained at 30-degree angle. Now, at the same angle, now in the same experiment, at each angle we obtain the first maxima. Therefore, we are using the condition for first minima, a sin theta is equal to lambda. Therefore, the width of a slit, a is equal to 2 lambda order. Now, for first maxima, condition is a sin theta 1 is equal to 2n plus 1 into lambda by 2. Here we substitute the n is equal to 1 for first minima, the first maxima. Therefore, a sin theta 1 is equal to 3 lambda by 2. Therefore, 2 lambda sin theta 1 is equal to 3 lambda by 2. Lambda is cancelled to the both sides. Therefore, sin theta 1 is equal to 3 by 4. Therefore, theta 1 is equal to sin inverse 3 by 4. Clear? Now, next it also depends on the intensity issue. The interference pattern is obtained with the two coherent light sources of intensity ratio n. That means the I1 upon I2 is given is equal to n is equal to A1 square upon A2 square. Therefore, we can write A1 upon A2 is equal to root n by 1. Root n by 1. Therefore, we can compare A1 is equal to root n, A2 is equal to. Now, we require the I maximum and I minimum first. I maximum upon I minimum is equal to A1 plus A2. A1 plus A2 whole square upon A1 minus A2 whole square is equal to root n plus 1 whole square upon root n minus 1 whole square. Right. Therefore, we can obtain the n plus 2 root n plus 1 upon n minus 2 root n minus 1. Now take the component into and divide into I maximum minus I minimum upon I maximum plus I minimum. Require this is right? Oh. So as we take the addition, subtraction in numerator, so we obtain the 2 root n upon here and denominator in plus 1. So that is our answer. So that is the totally mathematical. We have to simplify it. We obtain the answer is 2 root n upon n plus 1.